So the last paper of the exam, so the last question on the exam paper, and most people feel will be the hardest. Let's have a look. It tells us about two triangles, and it's telling us the lengths of them, but they've given them in terms of x, and they're telling us the areas are equal. So there's the trigger. There's the thing that tells us what we're going to be dealing with. So we're going to be dealing with the area of the triangles. So that suggests then that we need to be working with formulas to calculate the areas of these two triangles. Well, the first triangle is an any old triangle because it's not got a right angle in it, and therefore again, if we go back to the beginning of the formula sheet, then we can see that one of the formulas they give for any triangle is half ABC. Sine of C is the area of the triangle formula. So if we label our triangle up, there's our C, so this will be little c, there's our little b, there's our little a, so this will be big A and this will be big B. So for T1 we can see that the area equals a half AB sine of C, so that's going to be a half times the A value, which is x, times the B value, which is also x, times the sine of the C value, which is 30 degrees. So the sine of 30 is a half. I mean, you check on your calculator, but it's one of the ones you should really know. It's a common one. So the sine of 30 is a half. So we're doing a half times a half, which is a quarter, and x times x is x squared. So that area is a quarter x squared. Now for T2, we can see that it's about a triangle again. This time it's a right angle triangle. So this one we can use the straightforward formula that the base length times the vertical height halved is the area. So the area equals a half times the base length times the vertical height, which in this case is going to be a half of x minus 2 times x plus 1. Well, we've got our techniques for multiplying two brackets out, so this is going to be a half of x times x is x squared, negative 2 times x is negative 2x, but then we've got a positive x, so we're left with 1 negative x, and negative 2 times 1 is negative 2. So we're told that the areas are the same, so the areas are equal. So that shouts out at us that a quarter x squared is equal to a half of x squared take away x take away 2. So basically we want to rearrange and solve. Because this is a quarter, multiplying by 4 will cancel this to a whole x squared, but because I multiply this by 4, then I must multiply this side by 4, and 4 times a half is 2. So this becomes, if I times by 4, then it becomes x squared equals 2 lots of x squared. 4 times that is 2, so 2 lots of x squared, take away 2x, 2 times negative 2 is negative 4. So we can rearrange, so we end up with x squared take away 2x take away 4 equals 0. Complete the square. Now the reason we're going to complete the square is because they want the format to be like this. This format basically is saying to us, this format tells us to use complete the square. So complete the square is basically where you take this part and you turn it into x take away 1 all squared, take away 1 take away 4 equals 0. So we have x take away 1 all squared take away 5 equals 0. Rearranging, then we add the 5, so if we go there, then we end up with x take away 1 all squared equals 5. Square root both sides, so we end up with x minus 1 equals plus or minus the root of 5. So x equals 1 plus or minus the root of 5. So that will be our final answer because it wanted it in the form of a plus the root of b. Because it wants to be a positive value, again, when we look through the question, it says work out the value of x, give your answer 2. X will have to be a positive value because we can't have negative lengths. So the only positive value that comes from this is where we say that x is equal to 1 plus the root of 5. The root of 5 must be bigger than 2 because the root of 4 is 2. So if we did 1 take away 2, we'd end up with negative. So the only positive answer is 1 plus the root of 5. So again, this question, it looked complicated, but when you actually work it through, look for the triggers, and the trigger was that this was about the area of the triangles being equal. And then we got some formulas to work out the areas of the triangles. So work them out in terms of x. Then because the areas are equal, and that was a key point, the areas are equal, so we made them equal to each other, so we rearrange and solve. Times by 4 allowed us to get rid of the fractions, and that then gave us a simple quadratic that we need to rearrange and then solve by using the completing the square approach. So we ended up with our final answer of x equals 1 plus the root of 5.